All right, so we're in section 10.3. So the first thing we need to do is remember what we mean when we say a polygon is regular. So what does that tell us about the polygon? All the sides and angles are the same. So I'm going to draw a couple of regular polygons. We need to talk about the parts of regular polygons, just so we have some terminology. So I'm going to just use pentagons. So parts of regular polygons. We have a point in here that is the center. If I draw a segment from the center to each vertex, we call this angle the central angle. And we've talked about central angles of regular polygons before when we talked about our polygon angle formulas. The central angle of a polygon is 360 degrees divided by the number of sides. And I'm going to put a couple other parts on this one. We call the segment that goes from the center to a vertex, we call that a radius. And we call the segment that goes from the center to a side at a 90-degree angle, we call that the apothem. And on a regular polygon, the apothem cuts a side in half. And the apothem is going to be the key, or one of the keys, to finding the area of a regular polygon. Because what we're really going to do is use this triangle here, find the area of the triangle, and then add up a bunch of areas of triangles to find our area of our regular polygon. That's how we're going to come up with our formula. All right, questions about our parts? Well, now that we know this idea, we can use that to find angles in polygons. And finding angles is going to be important in finding areas. So finding angles. I'm going to stick with a pentagon, and we're just going to do an example. So I'm going to put in a center, put in a couple of radii, and an apothem, or apothem. Either one is an acceptable pronunciation. And I'm going to label these angles. This is angle 1, angle 2, and angle 3. And we want to find measure of angle 1, measure of angle 2, and the measure of angle 3. And I'm going to say this is a regular pentagon. Well, we know that the angle from the center that goes to each vertex, angle 1, is a central angle. So angle 1 is 360 divided by 5. And that gives me 72 degrees. And we know that this triangle that we make with the central angle we make with 2 radii, that's an isosceles triangle. So when I draw the apothem cuts the central angle in half. So the measure of angle 2 is 72, the central angle, divided by 2. So that gives me 36 degrees. Well, now we have 2 of the angles in this triangle, so we can figure out the third. 90 plus 36 is 126. Subtract from 180. So the measure of angle 3 is 54 degrees. So we can find all of those angles just by knowing that this is a regular pentagon. And we will use these angles in finding other pieces of our polygon. We can always use this process with a regular polygon. All right, questions? Okay, let's talk about how we're going to find our area formula. Our area formula is going to come from finding areas of triangles and adding them together. So I'm going to stay with my pentagon. And I'm going to draw in, we'll have a center, and I'm going to draw in 2 radii. And what I'm going to do is look at this triangle. And we're going to find the area of that triangle. I'm going to call this side B, for the base of the triangle. Well, to find the area of the triangle, I need the height. Well, the height of that triangle is the apothem of the polygon. And I'm going to call it A. So the area of the triangle, of one triangle, is the base times the height divided by 2. That's the area of that one triangle there. Well, if I divided this polygon into more of these triangles, how many total triangles would I have? I'd have one there, and one there. We'd have 5. So the total area is 5 times B times A divided by 2. Well, what is 5 for this polygon? What are 5 of these sides? If I added up this, and this. That's 5B, and that gives me what part of the polygon? The perimeter. 5 times B is the perimeter. And we could do that with a hexagon. We could do it with an octagon. We get the same thing. We'd be adding either 6 of those triangles, 8 of those triangles, however many sides we have. So our formula for a regular polygon is the area. Well, 5 times B is the perimeter. So I'm going to say the apothem times the perimeter divided by 2. A is the apothem, and P is the perimeter. And that comes from adding up the areas of all those triangles. That's why it looks like the formula for the area of a triangle. So to find our area of a regular polygon, apothem times the perimeter divided by 2. All right, questions? So that's our new area formula for a regular polygon. So let's look. I want to look at a couple of examples, and then we'll talk about special right triangles in certain polygons. We'll use special right triangles to find some of these pieces in some special kinds of polygons. So this is a regular pentagon. And we want to find the area. I'm going to say that's 12, and this is 8. Well, this problem is really nice because they give us all the information we need. I'm going to say this is in centimeters. The apothem is 8. The perimeter, find the perimeter. What am I going to do to find the perimeter here? 12 times 5, which is 60. So my area is the apothem times the perimeter divided by 2. 8 divided by 2 is 4, times 60 is 240 square centimeters. So that's a nice kind of problem because they give us all the information we need. All right, questions there? Now let's look at one that's a little trickier. Stay with a regular pentagon. And I'm going to say this is 11.88 and this is 14. And we want to find the area. So it's a regular pentagon. All right, do we have the apothem here? No, this is not the apothem. This is the radius. So we need to figure out the apothem. Let's draw it in. There's the apothem. That makes a 90-degree angle. There's the apothem. Well, what does the apothem do to this side? Cuts it in half. So this piece is 7. And what do we have here? We have a right triangle. And we have 2 sides. We need to figure out the third side. So we can use a Pythagorean theorem. I'll call this side B and this side C. So I get a squared plus 7 squared equals 11.88 squared. So a squared plus 49, 11.88 squared is 141.13. Subtract 49 from both sides. A squared is 92.13. And we take the square root of both sides to find the apothem. So A is 9.6. So we have the apothem. Now we can find the area. We need the perimeter. Perimeter is 14 times 5, which is 70. So we have 9.6 times 70 divided by 2. I plug that in my calculator, and I get 336 square units for my area. So if you have a radius, you end up having to use the Pythagorean theorem to find your asymptote. Yes? Mm-hmm. All right, questions there? All right, let's talk about special triangles in polygons. So there are a few kinds of polygons that are going to end up having special triangles in them. First one is a square. I'm going to draw two squares here. If we divide a square in half, the diagonals of the square, what do they do to these angles? Bisect them, we get a 45, 45, 90 triangle. So cutting a square in half gives us a 45, 45, 90 triangle. If we draw the center of the square, the apothem of the square has an apothem and a radius. This is a 90-degree angle, and this gives us a 45, 45, 90 triangle also. So if we make a little triangle with the apothem, the radius, we get a 45, 45, 90 triangle. And this is going to be half a side. So sometimes you're given a problem with this some piece of information there, and you need to use that little 45, 45, 90 triangle to find other pieces of information. So two different ways that we can get 45, 45, 90 triangle in a square. All right, we're good there. All right, the next one, an equilateral triangle. I'm going to draw two equilateral triangles. And we know for equilateral triangles, what are all the angles in an equilateral triangle? They have to be the same. So what is each one of them? 60 degrees. And I know if I draw this segment, if I divide that in half, I get a 90-degree angle, and that cuts this vertex angle in half. I get a 30, 60, 90 triangle. And this is half a side. If I draw the center, the apothem, equilateral triangles have an apothem and a radius. I also get a 30, 60, 90 triangle. And this is half a side. So sometimes you're given information about an equilateral triangle, and you need to use these one or the other of these 30, 60, 90 triangles to find other information. Yes. Mm-hmm. All right, the last one, last polygon, is a regular hexagon. And I'm just going to draw one regular hexagon here. And for the regular hexagon, we're going to draw in the center, the radius, and the apothem. Well, the central angle, label those. The central angle of a hexagon is 360 divided by 6, which is 120. And we know that the apothem divides it in half. So 360 divided by 6 is 60. The apothem divides it in half. And that's going to be 30 degrees. And that means that angle is 60 degrees. So we get a 30, 60, 90 triangle inside a regular hexagon. And we can use these 30, 60, 90 triangles, and this is half a side, to find missing pieces. We might need to use it to find the apothem. We might need to use it to find the side. We might need to use it to find the radius. Depending on the problem, we use these pieces of information to find other pieces of information. All right, questions there? Okay, I just want to do a couple of examples using these special right triangles to solve problems. This is an equilateral triangle. And we want to find the area. In simple radical form. And I'm going to say this side is 14 inches. Well, we know that the area is the base times the height divided by 2. Well, the base of this triangle, you know, is 14. And let's draw in the height. There's the height. Well, when we divide an equilateral triangle in half, we know we get a 30, 60, 90 triangle. And what is this little piece? That little piece is 7. This is the short side of the 30, 60, 90 triangle. To go from the short to the long, what do? Multiply by square root of 3. So the height is 7 square root 3. The base is 14. So our area is 14 times 7 square root 3 divided by 2. 14 divided by 2 is 7. 7 times 7 is 49. Yes. Mm-hmm. So that area in simple radical form is 49 square root 3 inches. All right, questions? Okay, last one. This is a regular hexagon. Oops, that's not a hexagon. And we want to find the area in simple radical form. Well, we know that we need the apothem to find the area, so let's draw it in. There's my apothem. And I'm going to draw in a radius because this little triangle is the key. And we know that's a 30, 60, 90 triangle. And what is this side? That's going to be half that side, so that's going to be 5. To go from the short to the long, multiply by the square root of 3. So the apothem is 5 square root 3. The perimeter is 6 times 10. We get 60. So our area is the apothem, 5 square root 3 times 60 divided by 2. 60 divided by 2 is 30. And we can multiply outside the square root. 30 times 5 is 150. Square root 3 square inches for my area. All right, questions? Okay.